Hello and welcome back to a short explanatory video. This time, I'll show you how easy it is to operate STOBER drives with Beckhoff TwinCAT. Previously, I introduced you to the device profile CIA402, and now we can put that to good use right here. Once again, we'll need a controller and STOBER drive technology, and motors for the movement. For this, we need a controller with the TwinCAT runtime and the EtherCAT master, as well as drive controllers from STOBER Antriebstechnik 6th generation SB, SC, SI, SD, with a STOBER gear motor, synchronous servo motor EZ, and one cable technology OCS. Parameterization and programming are carried out either directly on the controller's PC or via a separate laptop. The Drive Control Suite DS6 commissioning software from STOBER Antriebstechnik is also installed on it. Let's get started right away. We have already configured the axis as a CIA402 axis with user units in the controller and an interface of 2 to the power of something. 20 increments have been parameterized in the position, just like in the first video. The easiest way is to use the standard assignment of the process data and export the ESI file directly. If the application requires it, we can also change the process data transmission configuration here and here by adding new words and export a new ESI file. To import and use the file in TwinCAT 3, we save the XML file in the directory from which the controller reads it. In the standard installation, this is C TwinCAT 3.1 config IO EtherCAT. And then we restart the program, which reloads the descriptions. We create a new TwinCAT project. For the very next step, we will successfully connect to the controller. If we have created an EtherCAT master and are online in configuration mode and connected to the controller, then we don't need to add the STOBER drives individually offline in the planning. Instead, we can simply right-click to perform a scan and directly add the axis to the NC configuration. In our case, it found a double axis and a single axis from STOBER drive technology. For safety, we briefly check the most important settings in the EtherCAT slave. Is distributed clock activated? This is important for synchronous clocking. Transfer of the cyclic set points. Now we set the user units and limits of the axis in TwinCAT. In our case, one motor revolution should correspond to 200 mm modulo. We activate modulo on the axis and set the modulo factor to 2. Then we set the scaling to 200 mm divided by 2, raised to 20 increments via the interface. This gives us a numerical value, which we copy and then enter here at this point. Next, we download the configuration. Our EtherCAT slave reports operational. Let's head back to the axis settings and open up the online menu. From this screen, we can set the necessary bits and then enable the axis for use. And jog it. We can also see that at 200 mm the value overflows. With this, we can already check the mechanics. Next, we want to move the drive using the PLC program. To do this, we add a standard program to the PLC. Go to the references and add a new library here, Motion PDP, TC2MC2. This library contains the PL-Copin function blocks for controlling the axis. Now we can write a first small test program. We go into main. There's nothing in there yet, but I've prepared something that we can take from another project. We'll just copy that in here. We see the variable axis from the structure axis ref, and we can also copy the program calls, copy them over from the other program. There we see the call to MC power to enable the axis. We see the move relative command. If we are now in configuration mode, then we can simply, here at the axis, create the link with this axis structure, download the program, and go into run mode. So we have downloaded the program and we are logged in. Now we can enable the axis, have a travel distance of 200 millimeters with a speed not equal to 0. When we then start the relative move, we can also see how the axis continues to move. And with that, we have successfully moved the axis via the program for the first time. Now we are already done with the functions for the machine. Now we can add additional features like EOE so that we can tunnel drive control suite through EtherCAT. There are two topologies. In topology 1, the drive control suite is installed directly on the control PC. EOE is simply activated. On the master, you can activate the mailbox gateway. The slave addresses are assigned via DHCP. In topology 2, there is a separate service PC on which the drive control suite runs. We have two networks. One is the 192.168.6x network, and the other is the 10.0.0.x network within EtherCAT. On the master, the mailbox gateway is configured. You will find the same address here on the slave as well. We have assigned each slave a number by assigning it a fixed IP address. And now it's also necessary to add the route on the service PC for both networks. In case it doesn't work, it's definitely worth pinging the STOBER drive. On the service PC, it's important that UDP, TCP and the drive control suite are enabled in the firewall. And then in the drive control suite, we enter the IP address directly under direct connection. Furthermore, the developers at STOBER have also programmed a library with useful additional functions. Let's add that now. Previously, we downloaded the library from the STOBER website and installed it in the repository. Now we can select it here. Utilities Generation 6. The backup restore modules are particularly interesting as they allow you to easily back up and restore all parameters completely, for example with series machines or when replacing an axis during servicing. With the STOBER Action and STOBER Power Action modules, you can, for example, read out the nameplate, delete the axis reference or calibrate the motor, test the winding and optimize the current controller. The STOBER phase test module is also very helpful. Here, for example, you can determine the commutation angle. That was a brief overview. Let's take another look at the most important advantages together. You use qualified code that you have already used with another drive manufacturer. That saves you time. Your software quality remains high. You have seamless integration into the Beckhoff control environment, just like with any other standard drive, by simply using the control drives of the 6th generation. You remain independent and free in your decision about which drive manufacturer you want to consider next time. You are not locked in or confined to a proprietary solution. And in any case, you can implement a dual supplier strategy. And last but not least, you save manpower. You are not dependent on using true programming specialists, freelance artists. Instead, you rely on open standards like CIA 402, PL Copen, IEC 61131, and EtherCAT. That was really exciting. Thank you for sticking with us for so long. I'm looking forward to having you join us again for the next video. Until then, take care and have fun with STOBER drive technology.